Hello, welcome back to Francis Kelsey, Pre-Calculus 12. Still with Learning Guide 4, Logarithmic Functions. We are now on part 3. All right, topic 3 is looking at the laws of logs. So we're going to go through the various laws. First one we're going to do is called powers. Okay, so we have to write an expression that is equal to the following expression. Okay, so let's have a look at this. Log pi squared. Now when you're dealing with logs, when you have a power here, this 2 right here, what happens with that 2 is the 2 will come down in front. It's just one of the features with logs. So we would write it as 2 in front, log pi. And that is our expression that is equal. Okay, so the next one, log the square root of x. All right, now we dealt with square roots before, so we're going to change that square root into a power, because you want to be looking at powers if you can. So we have log x, and remember this has got an invisible 1 there, an invisible 2 there, you can't see it, but it's called a square root. So we know it's 1 over 2, okay? So now we know this comes down in front, just like the previous question. So it's going to get us 1/2 log x. Okay, so it's pretty straightforward when you're dealing with logs, with exponents or powers. Okay, so the power will just come down in front of the log. And it can go backwards too, which we'll see later. We can go from the front back up to the power. Okay, so I want you to try the bottom two. So you can pause it for a second and try the question and check my answer. Here's the answer. N log n. And this one will be 1/2 log base 2, don't forget the base 2 to 8, the argument. Okay. Now, next question. We're going to look at the laws, and remember that there are some things you have to remember. That if x and n are real numbers, x has got to be greater than 0. So we need to remember that. And a, the base, cannot be 1. And we dealt with that earlier. So use the laws to simplify the following. So these ones here, very similar to the ones we just did. So this would be 5. Remember this, power's coming down in front. Log to x. And if I asked you what's the base in this log, there's no number here, so it's base 10. So remember that. This one here, oh, we got some fancy radicals going on. So just remember your roots are powers. So remember the y, the one in here, goes as your numerator, and the index becomes your denominator. Okay, so this here, there's an invisible 1 there, so I'll put a 1 there. So this would be written as log y to 1/5. Okay, now we know the 1/5 comes down in front, and we know the answer will be 1/5 log y. Okay, so there's that one. And this one, same thing. The 3/4 comes down in front. Log base 2. Now we have a base in this one, so don't forget to write the base in. And we're done. Okay, so let's just recap this. So remember, the 4 comes down as log m. Now, you have to remember what we taught you earlier, that when you have a base, like in this case m, that matches the argument, you can simplify more. So that's 1. So we get an answer of just 4 there. Okay? So you can do a lot with these base changes. So let's try these ones below. Okay, so you have to really think bases here to simplify. All right, so we know the 5 is coming down. So it's 5. And then we just write out log base 7 to 49. Okay. Now, this part right here, I'm just going to get a different color. This right here, this bracket, I'll make a bracket right here. We can simplify this. So we need to simplify that. So what we're saying is 7 to what power? 7 to what power? I'll just put a little x equals 49. So this one is a pretty simple one we can do in our head. We don't have to really think too hard. We know 7 squared. So now this equals a 2, that bracket, simplified. Now this 5 just drops down, okay, and you now multiply, because this was a bracket, right? So 5 times 2, and the simplified answer you would write is 10. Okay? So your answer is 10. So all that work is just to get the 10. Okay, now the next one. Log base 8 to 2x. Okay, the power law taught us that it comes down in front. So we have x log base 8. Okay, so it's a base 8 down here to 2. Okay, so now 8 to what power equals 2? Well, that's a little tricky because I can't think of 8 to what power equals 2. So now we're going to do a little rule for these guys. And it's a really cool rule that you're going to use quite a bit. And it's called the Leslie-Whittaker rule. I'll say the Leslie. Leslie Whittaker was a student we had a few years back, and she invented this cool rule that that helps us solve these sort of trickier ones. They're basically ones with exponents. So I'm going to look at this 8. Now, I want to make it the same base, because remember I told you, think bases. So I can make 8 base 2 quite easily. So watch this right here. I'm just going to take this guy right here and simplify it. So I'm going to go log, okay, that 8 I'm going to write as 2, base 2 cubed, because 2 cubed is 8. Same thing, because I got a 2 waiting here. All right, so now I have a 2 and a 2, and we know back up to this rule is m and m, we can get a cancellation out. However, we still have this x here, so don't forget about the x. It hasn't disappeared. Okay, the x is still there. But now what we're going to do, let's go over here, is the Leslie-Whittaker rule. So what she sort of discovered was just using powers. So again, I'm just gonna simplify this thing right here, this bracket, and then we'll deal with the x at the end. she told us that if there's a power there, because 2 to the power 1, if that comes down in front and this comes in front, you now have 1 over 3. Because that power in the base comes as the denominator, and this power in the argument becomes a numerator. You have now log base 2 to the argument 2, which is great because we can simplify now. Because now we know that this base 2 to 2 is really 1. So we could say it's just 1, or it cancels out. So we have that 1/3. And remember, I told you about that x. It just floats down in front now. And you take that, and you take the x and you times it by that. So you get x over 3. Okay? Or some people write it as, or I'll say, or 1/3 x. You can write it either way. They're both acceptable. Okay? All right, so let's look at this one. Same thing going on here. I got a half as the base and a 16 as the argument. My brain is thinking base 2. So I'm going to go right to a base 2. And let's see if we can get a cancellation out. So 1/2 is, remember, 2 to the negative 1. And 16 is 2 to the power of 4. And now we know that the 4 comes down in front, and this negative 1 comes out in front as the denominator. So now we get 4 over negative 1 of log base 2 to 2. Okay? And guess what? We have a cancellation out right here. That's gone. So our final answer is negative 4. Okay? So that Leslie Whittaker rule is something really pretty crafty.